Hi. Alright, so let's talk a little bit about Project 3. So I'm assuming you've looked at the spec to some degree, maybe you've watched Alan's video, but you have a rough idea that what we're building is a mapping application that you can scroll around the city of Berkeley, you can double click in one place, double click in another, and get a route, and that's what you're going to do. Okay? So I want to talk about the first part of this assignment, namely the rastering part, because I think it's a little challenging to understand exactly what you're supposed to do. So I put together some slides that I'm going to be going through that you can read, and I posted them on Piazza, and I think I will link them to the spec if they're not already. And so I'll say that the very first thing that you want to do is you should make sure your code compiles and that you can open localhost 4567 and see the blank screen. So that was something that was in an earlier lab, but when you do this, you should see all of this pink text and you should not see the map. So that's job one. Make sure you can do that. The second part, well, make sure you read through the spec. And I want to let you know that it's going to feel like there's a bunch of holes in your understanding. And that's actually pretty normal when it comes to building a big system. So you'll get some spec, and you'll kind of get it, and you'll have to figure out what's going on. You know, often whenever you build a big project like this, you'll be starting from someone else's code base, and it's going to take you a while to spin up. Okay? So that's okay. That feeling of wow, this seems like a lot to digest is fully normal, but it's really exciting once you get really comfortable. I get free Office. Go away. And so it'll take a while whenever you're doing a project this to really feel like you're on top of things, but once you get it, it'll feel good. So these slides are basically here to give you an acceleration, because whenever you work at, say, an internship or a job, ideally the person who developed what has already been done is there to sit down with you and work with you to get you and understand things. So this will be the closest approximation of that. But I will say that you should feel totally free to just insert code that's just to further your understanding. And I'll give some tips towards the end of the the video, what I'll call step 3. Things like you can write little pieces just to build your understanding, or you can write things that are helper methods you'll need later, even if you don't understand everything all at once. Okay? It'll take time. Okay? So as I've alluded, the hardest part of this project is getting started on this function called getMapRaster. Okay? The first big thing you need to do, really big thing, is to write this method getMapRaster. So let's talk about what this method does. Okay? So this method is given some parameters. That's an argument. That's what the user wants. And it's also given another parameter or argument called OS. And that's going to be the place that we put images. In this case, it means output stream, not operating system. And then what your code's supposed to do is take the query that's given to you here and write the image to OS. So you're going to return some kind of results, but you're also going to send some information out into the world. Yeah, I'll talk more about this API in a bit, but that's the words that go with it. But the understanding will come in a bit. Okay? So let's get an example of what an input might look like. So we might get a params array, a params map that looks like this. We have a map from the string ulon to -122.24 and so forth. So we have a ulon, lrlon, w, h, olat, and lrlat parameter. Okay? So these are described in the spec, and there's an image, but this is to help accelerate your understanding. But that's the example. That's an example of an input you'll get. Okay? So let's talk about what this means. Well, the user is asking that I would like to see everything with x coordinates between this right here and this value right here. So this number, you'll notice this is the bottom right corner and this is the left corner. So it's saying everything between these two positions is the longitude we care about, and I want everything between these two latitudes or y positions. Okay? And so that's going to be our query box. Okay? So that's the latitude and longitude that the user wants to see. So in other words, that's basically this top left corner to this bottom right corner. That's what the argument you're going to be given is. Okay? Now it's not just that though. In order to pick the images that you need to display, which we'll describe in a little bit, you also need to know how wide and how tall the user's browser window is, okay, approximately. So it's like the display window. So it's 892 pixels wide, so your screen is made up of a bunch of discrete pixels, and in this case, we're trying to display it in a space 892 pixels wide by 875 pixels tall. Okay, that's what the interpretation is. We have the width of the window, the height of the window, the latitude and longitude that you want in the top left, and the latitude and longitude in the bottom right. Okay, so let's see a little example here. Okay, so I want to make an observation here, which is that at our latitude, so we were at about 38 degrees north. It turns out that each degree of longitude is about 288,000 feet. Okay, So I'm bringing that up because I think the examples I'm going to go through in this lecture this video make a lot more sense if we're talking about feet and not longitude units, right? I mean, these numbers are so tiny. The difference between 122.241632 and 122.24053 is so small. So I'm going to use the scaling factor to bring things into terms we can understand. Okay. So the parameters tell us that the user wants a box which is 317 feet wide. In other words, if you look at this is much more than 317 feet. This is a long distance. Like 317 feet would be zoomed in considerably. Way more, right? Somewhere down here, okay? So the user in this case, we can interpret the params to mean that we want 317 feet in longitude, and that the user wants those 317 feet to be drawn on a space that's 892 pixels wide, okay? And so thus, what the user is basically asking is they want an image that has a resolution of 0.355 feet per pixel. So if we go through and we count off pixels, here's one pixel, here's another, here's another, here's another, here's another. Well, it's not to scale, obviously. I can't move my mouse one pixel. I don't have the skill. But if I could move one pixel at a time, it's basically saying the user wants an image that's zoomed in such that each pixel represents 0.355 feet, which is pretty zoomed in, right? That is not the case here at this level of zoom I'm showing. All right. So that's basically the ground rules of what we're trying to solve. Now, I want to make a note here that we don't really care about the latitude density. It should be about the same. I could have also done the calculation ulat minus lrlat divided by h, but if you look in the spec, the only thing you're required to do is cover the appropriate density in the longitude direction. So that's all you need to worry about. So hopefully at this point you understand what we're trying to do. The user gives us top left, bottom right, width, height, and we can use that and interpret it in the way we've now described. Okay, if you don't get that, maybe you go back and rewatch it. Maybe sit down, or I don't know, maybe watch forward and see where you go. But I do really want you guys to be able to understand this without ideally asking other people. Now, if you're a non-native English speaker, maybe the spec's hard to read and maybe my explanation's not great. I understand. But, maybe turn to Piazza. But ideally, you'll be able to get this specification just from what you've read and this video. Okay. So what does this query tell us? Well, it turns out that if we plug these numbers into the solution, which I have, you get this picture right here. This is what we want to display. That query, this is the 312 feet that we want to show, and here are the width and heights that are given in these parameters. Okay, so 892 by 875 pixels in this box. So this is the image your program's supposed to supply. Okay, and we're just going to talk about it at the high level for now. What it's semantically supposed to do, its goal. And so there's two critical requirements that are listed in the spec. One, you need to draw this entire box. You must show everything between these coordinates. And two, you have to make sure you have enough density, right? And as before, we said that we need a density of around 0.355 feet per pixel. It should look nice. So let's consider an example of files we might need to use. Now you'll notice that I'm wearing different clothes than I was just a few seconds ago, and I'll be putting on my clothes that I had on before again soon. But basically what happened was I realized there was a small technical little bug in here that I decided to re-record to avoid confusion. So what we want to do in this case, one particular image we might try and use to satisfy the user's desires is to display for them 2.png. Okay? What is 2.png? Well, if we open up all of those files that were given, here's 2.png, this is a picture of the top right corner of the Berkeley map. And we'll notice that it actually contains that little piece of Centennial Drive, that we want to display. There it is. Okay? So the image here, 2.png, wholly contains everything the user wants, but there's a problem. Its resolution is too coarse. In particular, this image, 2.png, has a resolution of 49.41 feet per pixel. So if you look at this image and I scoot one little bit over, 1 pixel, 1 pixel, 1 pixel, 1 pixel, each time I move a pixel over, we're changing by 49 feet per pixel because the image is so many units of longitude, and it is, if you look at its properties, file info, maybe it'll even tell me, 256 by 256. So its image density, or the pixel density here, the distance per pixel is 49.41 feet per pixel, much too low. So what about 2.1? We zoom in and we take the top left corner of this image and we get this, right? So notice this right here. If we take the top left corner, it should just be the stuff, so we'll see this wiggly road, and there it is, that wiggly road. So in this case, The query box is again wholly contained within the image we might serve to the user, 21.png, but its pixel, its density is just also way too coarse. It's 24.88 feet per pixel. So while it's better than 49.41, it is not good enough, because remember again, the user wants a high resolution image that's 0.355 feet per pixel, so they can actually see the thing that they are looking for. Okay. So as a test of your understanding, a little different than if you saw the video yesterday, which probably you didn't, otherwise you wouldn't be watching it, is to ask how many digits will be in the file name for the lowest resolution file that is good enough. So for example, we could take a file with like 1,000,000 digits. That's obviously going to have a good enough resolution. So we want to get the best, the file that is just good enough to meet this requirement. So think about that for a second, and I'll patiently wait. Okay, so hopefully you came up with the fact that it should be a 9-digit file name. And you can work out a pattern, you can write a formula. I mean, you don't have to do this. You can just keep dividing by 2. And you can show that for, suppose we had n equals 8 digits. So in that case, the feet per pixel would be 0.386 feet per pixel, which is just a little too coarse. So we go one more level, and we get 0.193 feet per pixel. Okay. So in theory, the images that we want to use should have 9 digits in the file name. But if we look at these file names, you'll note that they actually only get so long, right? There's only 7 digits. Okay. And so while we'd want a 9-digit file, we have to just settle with 7-digit files, which is the highest resolution we have available. However, if the user has a larger query box, it may be the case that you don't need to go all the way down to that bottom level. Maybe just 1.png is good enough. Okay. So that said, let's consider this file, 2143411. So it turns out that that image right there, 2143411, it is the top left corner of what we're looking for. So let me go back and remind you what we're looking for. This image right here. This is what the user wants. They want this box. So 2143411 is that top left corner. And we'll make an observation that's different here, which is that while this resolution's good enough, I mean only good enough because it's the best we have available, it does not cover the entire query box. So if you show this, part of the window would be empty. So what we actually need is additional images here, right? So this query box is larger than what this image shows. So you can maybe eyeball it and say it looks like we need maybe 2 more images. It could be 3, but if you work out the math and you look at the images that are available, you realize it's actually 9 images. Okay? So if we take 9 images and we tile them together in a process we'll call rastering, what you'll end up with then is the entire picture the user wants. And here you can kind of see the little bit of seam between the edges, right? And that's just an artifact of the way that I produced these slides. So it turns out that 2143411, 2143412, and so forth, that these 9 images constitute the best available images that will satisfy the user's request for this box that they've requested. And so I'll note that the tiles that we have here, these 3x3 tiles, they actually cover a little bit more space than the user's requested box, and that's totally fine, right? It's okay that we're giving a little bit more than they asked for. To further your understanding of how all these images works, I've provided this file display demo. It's provided as part of the spec, or you can get it from the link in the slides, or laboriously type this out from this video. You can actually type in the name of a file, and it will tell you all the properties of that file and give you a nice visualization. So for example, file 2 has these corners, it has this pixel density in distance per pixel, and it has this density in feet per pixel based on a 256 tile. An earlier version of this tool said 400 by 400, but that was unnecessarily complicated because the actual files you're given are 256 by 256, so I've written it so it matches these perfectly. And so you can use this to say, okay, well, what about like the image 322? Okay, well, that one's there. It has these corners and this density, and you can play around with it and ensure that all the stuff that I've said in the video, like you can take this picture, for example, put it in, and you'll say, oh, okay, that's that little box. It has all these densities, 0.773, yada, yada. Okay. So make sure you use that tool if you'd like to further your understanding of how all the little pieces work. So back to what we were discussing then. So now that we have a high-level picture of what the rastering process entails, it says, given a box, find me the appropriate images that I can stitch together to show the user what they want. So how do we actually relay it to the user? So I know that the user, in terms of the code, get map raster, that it takes an argument called params, and it takes another one called os, and it's somehow supposed to spit out this image. Now, usually, whenever you're programming, you ideally want something really nice, where someone gives you inputs and you return the outputs. That's the normal way we do business, right? That's just when you write programs, that's what you're used to. In 61A, all the time, we give you a function and you just fill in the blanks and you'd return the appropriate value. We've occasionally done something a little different. Sometimes you have to write output to a file. Sometimes you need to do something crazy with JavaFX. And so this is going to be one of those situations where we're not just returning a value, but instead we're doing something more complicated. In particular, your getMapRaster function is supposed to do two things. One, it's supposed to return it's supposed to return a map that contains all the information about the results of the rastering process except the image. So in particular, you see raster ULON, raster LRLON, raster LRLAT, raster ULLAT. These parameters right here specify what values we actually gave the user. So the user asked for this purple stuff, and we gave them this red stuff, right? Notice this is 122.24212, right? Matches that. So we're saying this is what we actually gave the user. And that's going to be useful to the JavaScript HTML renderer thing that is going to be accepting your data. So in other words, this program right here, it expects that parameter. So you need to make sure to give it. It also tells you what the height and width of the rastered image is. And since each image is 256 pixels, you're giving it 768 in this case, because you're saying I'm giving you 768, that's 256 times 3, by 768. Okay? And then finally, you're supposed to say what depth you went to. So in our case, it was file names of link 7. So you need to make sure to supply that to the map HTML by returning it as a return value. What about the image? Well, the image is not returned as part of this map. You could, in principle, do something like that. But what we opted for, to make things easier for the HTML file, is you're supposed to write it to an output stream. What is an output stream? Great question. And I'll have a couple little tips about that. But really, that's not actually a major concern for you at this point, right? You can write getMapRaster, do almost all the work without understanding what an output stream is, and then later, that's something you can work on when you're ready, okay? But it's basically an object, and we're going to link you to documentation, and part of the challenge of the assignment is going to be figure out how to actually write to an output stream appropriately, okay? All right. So again, don't miss that demo I did where I showed how to look up those files. And I want you guys to use it if everything so far has not totally made sense. Okay. So now some programming tips, just a few. So step 3, earlier I gave you 2 steps. Now that I think you have a better understanding, hopefully, make sure you know how to hello world. Remember I use this phrase hello worlding when it comes to programming. You want to make sure that you can work on things in really simple contexts. If you try and just write your way through the whole program in one giant method, changing a little bit at a time and kind of crossing your fingers, it's going to be a little scary. So what I'm going to recommend that you do is you occasionally write code that's just there to further your understanding. So as an example of this, what you might do is edit your mapserver.java. So it starts with these 2 lines of code. When you look at the skeleton, you might consider adding just a little print statement here that prints out params. Then what you should do is run mapserver and try opening up test.html. Okay? And if you do that, you should see something like this, right? It's going to say all this magical stuff. And then whenever you go to your browser and you open up test.html, you won't see this picture here, right? Because you haven't written the code that finds the 9 images and stitches them together and outputs them however they're supposed to be output. You'll probably just see a blank screen in your browser. However, if you look in your Java, on your IntelliJ window, or the command line as you may be running it, you should see these numbers get printed out because you have this print statement here, and these numbers should match exactly. Okay? If they don't match exactly, then that means you probably have an old version of the skeleton, so make sure to repull. Now I'll note that it's okay if they're actually printed in a different order, but the numbers themselves, they must be the same. Okay? So that's an example of something you might do that will help you get started. Okay? Now, other general tips. I'm going to strongly recommend that you break your goals down into smaller tasks. Now that you have a rough picture of what you're supposed to do, right? Someone gives you a box, you need to render some images, you should think about all the sub-pieces. And I know that in Project 2, one of the big challenges was figuring out how to modularize your design and step through in little pieces. So let me give a couple suggestions, because Project 3, it's a shorter turnaround, so I want to make sure we can expediently move forward. So given a query, What do I mean by that? A box, right? Someone gives you a query. This is the box here. You need to find all the file names that go with that query. In other words, you need to write the code that, given this box, it gives you these 9 file names in this case. Okay? That's an example of something you can do. You can write a helper method that, given a query box, returns a list of file names, something like that. You can even test it against the example in this video and make sure it works. And in that case, you don't have to even worry about opening the files, writing out to the output stream. You don't have to worry even about returning the appropriate parameters here. You can just check that list. So that's a good example. Maybe a great place to start. So we have an example in the assignment spec that you could build a quad tree recursively and build some kind of querying operation. I'm not really going to talk about that here, but that's one approach, probably the best. Another example of a small task you might do. Given a list of file names, write them to an output stream. And as the spec notes, it says, we expect you to Google it. Here's some suggestions. Try it out. And if this ends up being especially onerous, maybe I can give some more tips. But really, I want you guys to get to the point where when you're faced with a task like this, where you're using a new object, say like an output stream, you can feel comfortable enough that even if you don't fully understand something, you can break it down into little pieces, and you can do what I called in the previous project, hello worlding, where you just write a little dummy function. So what might that look like, right? So what you could do is you could replace get map raster with a function that all it does is it just writes like 1.png and 2.png into the output stream and displays it. It doesn't try to do anything fancy. The only goal is to write it to the output stream. And how do you know it works? Well, if you read the spec carefully, you will see that if you, well, actually, maybe I'll point it out. This is a subtle point, easy to miss. Let's see, let's grab the spec. Okay, so query success. All right, so it says here, when getting started, you can just write an image to the output stream OS and set query success to true, and it will show up on test.html. So that's an example of how you can hello world the process of writing something. And in that case, ideally you can get it so that the image you're looking for appears here. It's not going to be the nice one. It's not going to be this 3x3. It's just going to be whatever random file you pick. But it'll tell you that you have your hands on the reins of power, that you can control things. Okay? So I'm just going to emphasize that is so important in software engineering, especially as a novice, to get comfortable with the idea that I have some task. And I have a big task that's complicated, and I have some task, some little piece that's very hard. Okay? But rather than trying to plug my solution to the whole problem in and make sure it works, I'm just going to do this little piece. And I know that's a little vague, but it's just supremely important. So before trying to write the correct set of many images, that is, before trying to raster out this entire 9x9, maybe just try and write one of them, right? Write just some file, just to make sure you know how to get it to show up in the browser. And then once you do that, you know, you've learned, it's like learning how to walk before you run. You're not just going to jump right out of the womb and just start sprinting, right? It's just not how it works. You got to learn to crawl and then walk and then run. So make sure you're doing that, especially on this project. Once you've got it so that you can write one image to the browser, now start trying to do 2 images. Maybe try and get it so that you can write those 9 images just hard-coded. Okay? And so those kind of things are going to make your Project 3 experience a lot better. And what's even better, then whenever you have questions for the TAs or on Piazza, you have a very specific query. Instead of just saying, well, I open up map and nothing happens, you can say, okay, you know, I have the collection of file names working perfectly, but now I'm just trying to write images, and we can focus on that, and it'll make your life much better. Okay? So again, take things a little at a time. And if you just try to write a bunch of code, this is the same exact advice I gave on Project 1. It's going to cause a lot of grief. And if you find that something I've just added isn't working, you know, comment it out, back up a little, and hopefully things will work out better. Okay, so Alan is going to go through and do this and explain these quad tree construction tips on his own video. And I'm going to call it a day for here. You know, I may add a little bit more, but I really hope at this point you've got the foundation, because I do want you guys to build independence as programmers. I know the class is very challenging, and I hope that you've appreciated those challenges. And really this project, a lot of it is just about understanding where you're going. There's not a lot of intricate coding, and I don't think you're going to beat your heads against the wall nearly as much in Project 2. But really work efficiently and don't waste your time. Like if you are really truly stuck, talk to someone else, talk on Piazza, and ideally you have some group of people that you know that you can work with, because it is a big challenge, and I want to push you guys and get you to the point where you can do really amazing things. Okay, that's it for this video. I'll see you next time.